Hello and welcome to today's lesson on box plots. So it's first worth thinking about what a box plot is. Now a box plot is a way of representing data by splitting it up into quarters. So splitting it up into 4 different parts. So let's think about something if we had, 200 people. So if I had 200 people, and I wanted to split these up into quarters, and we wanted to see a particular value there, the way we'd split it up is we'd have, now this is what a box plot looks like so. And this would be then, if this is split up into quarters, and now it's the value of the thing that you want in that quarter. We'll talk about that a little bit later. So this would be split up into, well, what's a quarter of 200? A quarter of 200 is 50. So this is here split up into 50 people here, 50 people here, 50 people here, and 50 people here. So it's split up into those quarters. Now, these lines represent different parts of it. So this is your lowest value here, and it's important to know that. This part here is your lower quarter, or your lower quartile. Okay, this one here is like your middle person, or another word for that would be your median. Hey diddle diddle, the median's in the middle. Okay, so this is your median. This one here is equal to your upper quartile. And this last one here is your highest value. Now, it's probably worth getting that in your notes, okay? Because this is your starting point for box plots. And if you understand this, then it does make a lot of sense. And it should be pretty easy. So let's have a look at these first few questions. Now, these are pretty easy if you know this, okay? So let's have a look at this first question. So write down the value of the median. I'll make it big for you so you can see it. I think everybody should be able to do this right now. So write down the value of the median. So having a little look at this, we have got here, the median is going to be that middle value here, like this one. So we need to see how far across that is. So it's going to be 1, 2. So that is going to be the first example. With your box plot throughout, example 1, my median is equal to 20, just make sure that's right. Yeah, 22. Brilliant. Okay, so that's example 1. Write down the value of your lower quartile. Well, we know the lower quartile is this part here. So for example 2, where is my lower quartile? Well, my lower quartile here is equal to 1, 2. It's 2 across from that again. These are split up into 1s. So it's 10, 11, 12. So my lower quartile for this one is equal to 12. Let's just check those right. Make sure I've read those graphs right. So here, let's have a little look. 22 and 12, absolutely perfect, super. So let's have a look at these next ones. Now what I'm going to suggest is, if you think you can do this now, maybe pause and have a little think about what you'd get. So I'll make it big for you so you can see it. So let's have a little look at these ones together. So write down the maximum value of this. I'm going to do it here just to save a bit of space. So again, we need to think about where our maximum value is. Now this is the highest, so it's that line at the top. So for example 3, where is my maximum value? Well, my maximum value here is going to be, well, that's going to be 45 for the maximum value. Brilliant. And then for our minimum value on this one, well, you notice that I'm 2 back from 10. So my minimum value for that one, which is going to be that furthest point there, is going to be equal to 8. Brilliant. So let's just check those. 45 and 8, super, brilliant. So let's move on from this. So what we're going to be looking at next is something which is called the interquartile range. Now, if you've seen the quartiles video, then you might already know what the interquartile range is. But let's just have a little think about what that is before we start this. So you know that your range, hey diddle diddle, the median's in the middle, you add and divide for the mean, the mode is the one which is the most, and the range is the difference between, so the biggest take away the smallest. So the range in this one would be the biggest, which was 45, take away the smallest, which is 5. So the range would be that, but it's not asking for the range. It's asking for the interquartile range. Okay. Now the interquartile range, and again, it's worth getting this in your notes. Sometimes you write it like this: your interquartile range, okay, is equal to, well, your range is your biggest takeaway, your smallest. Your interquartile range is your upper quartile. Subtract your lower quartile. Now, the reason that you'd use the interquartile range is because it's a better measure of a spread for the actual data. It's not just your biggest and your smallest, because you might have outliers at those extreme ends, which means that your range is skewed. So this is looking at just 50% of that data, thinking about this again. So it's just looking at here, which is these two quarters, so it's only looking at 50% of your data, which is a much more accurate measure of range. So let's have a look at this one then, example 1, so example 5 on here. Example 5, so remember your interquartile range is equal to your upper quartile take away your lower quartile. So what's my upper quartile with this one? Well, my upper quartile is that line here, which is on 35. So 35 subtract my lower quartile, which in this case is equal to 16. So 35 take away 16. So 35 subtract 16, you should be able to do this in your head, but I'll do it anyway, is equal to 19. So that's your interquartile range for that first one, is equal to 19. So pause now and have a little go at that one on the right yourself. It shouldn't take you too long. Okay, let's have a little look at it together. So you know your interquartile range for this one is your upper quartile take away your lower quartile. So my interquartile range is equal to my upper quartile, which in this case is 46. Subtract my lower quartile, which in this case is 19. So 46 take away 19, 46 subtract 19 is equal to 27. Brilliant. So, we've done what the box plot is now. We've done the interquartile range. The thing that always comes up with these is this. And it always comes up with this. So the question always states, give two comparisons of this. Now, when you're doing comparisons, the thing that you're always going to check is the median and the interquartile range. These are always the two things that you need to compare. Okay, it doesn't care about checking the highest, it doesn't care about checking the lowest. You're looking at the median and the interquartile range, and if you don't do those, then you will lose the marks. People look at these comparisons and they say, for example, if this is looking at the length of cucumbers, they say, well, the highest in the garden was this, the highest in the greenhouse was this, the lowest in the garden. They don't want that. They don't want to look at that. What they're looking for here is they're looking for a comparison of the median and the interquartile range. So let's have a look at this one together. So this one here now is example 7. Example 7. So, let's have a look at the median first. So let's first work out what the medians are. So in the median in the greenhouse is equal to, let's put one there. So it's going to be 1, 2, 3 over from 25. So the median in the greenhouse is 28. The median in the garden is equal to 27, sorry. 27, yeah, that makes sense. So we've got the median in the greenhouse, we've got the median in the garden, we also need the interquartile range for this. So the interquartile range for this one, so for the interquartile range for the greenhouse is equal to, well, what's that upper quartile there? The upper quartile is 32. Subtract the lower quartile, which in this case is 21. And then the interquartile range for the garden is equal to 35 subtract 20. Brilliant. So let's work out what those two are. So 32 subtract 21, which is in this case is equal to 11. And then 35 subtract 20, which in this case is equal to 15. So then you make your comparison. So we've got all of these now. So if you've got this, you don't need to write the actual numbers down because you've already got this on the paper. But I will say the median in the greenhouse is greater than the garden. So the median in the greenhouse is greater than the garden. And the interquartile range in the garden is greater than the interquartile range in the garden is bigger than in the greenhouse. Now, the only reason I can just state it like that is because I've got all these numbers up here and they're very, very clear. If you didn't have these numbers like this, you would need to put them in here. So the median in the greenhouse is 28. The median in the garden is 27. So the median in the greenhouse is bigger than the garden. The interquartile range in the garden is 15. The interquartile range in the greenhouse is 11. So the interquartile range in the garden is bigger than the greenhouse. So that's that question done. Now there's a lot of work to do there, and a lot of people miss out on these 3 marks because they always just compare the heights or the greatest or the smallest and things like that. So you need to make sure you're setting it out correctly. And this topic can seem easy, but people forget every time. Okay, so just make sure you take your time. So we've got another one here. Pause now and have a little go at this one yourself. So pause now and have a little go at that one. Okay, so let's have a little look at this one together. So some of these details you actually already have. Okay, now I know this picture might be quite small on this screen, so hopefully you can see it. Even I'm struggling a little bit to see this. So let's have a little look then. So this is just asking you to fill in that table. So they've got 2 here. The top one's the Year 11 girls and the bottom one's the Year 7 girls. So we've got our table like so. We've got Year 11, we've got Year 7, and then we've got the median, we've got the interquartile range, and I've got my range, which is there like so. So first of all, the median of the Year 11s, we can just see from the table there, is 165. We do need the median from the girls, which is very tricky to see, that one. It's halfway between. So that one there is going to be 175, 157.5. The interquartile range, we've already told you interquartile range for the Year 11s, which was 7. The interquartile range for the Year 7s is 65. Take away, it's tricky, that one is halfway between, isn't it? 69.5. So let's write that down. Interquartile range is equal to 65 subtract 54, that is 54.5. 54.5, let's do it on calculator. 165 subtract 154.5, which is equal to 10.5. There we go, let's put it in there. And then the range for this one, again, we've already got the range for the year 11s, that's 20. And the range for the year 7 girls that's 70, 70.5. Subtract the smallest, which in that case is 146, which is equal to 24.5. It's tricky there because you've got some of the parts inside it. These are all in centimetres. Let's just check that answer. Can't see it very well there. 165, 720. Yeah, good. 157.5. Yes. 10.5, brilliant. And 24.5, brilliant. Good. So there is one more type of question which I want to look at. Okay. Now this is the one that people always mess up because they forget one fact. So I'll make it big so you can see it because I do want you to get this one in your notes, or at least have a real think about it. Okay. So let's read it out together. The box plot gives the information about the distribution of height in the trees in the woods. There are 300 trees in the woods. Work out the number of trees in the woods with a height of more than 17. Now, the thing that we need to spot with this is that 17 on this diagram here, if I look here, 17 is the upper quartile. Okay, 17 there is the upper quartile. So we have to think about going back all the way back to this part here. So going back to this little bit part here. If we know this here, we said that this was split up into 25%. So each part represents a quarter. Like so. Each part here represents a quarter. So if I know that 17 is at that quarter mark there, that upper quarter, it means that the amount of people who are greater than 17 is going to be this part here, which is 25%. Okay? So work out the number of trees in the woods with a height of 17 or more. So let's just make that really clear. Let's get a new sheet. So we've got here our box plot. Okay, there's our box plot. We've got here this part. And we know that this is 17, and we know that this represents 25%. So if we want the amount of people which is more than this, we've got to find 20% of 300. Now, there's a few ways you can find 25%. You can either find 10%, times it by 2, then find 5% and add it on. But the best and easiest way to find 25% is to know that this is a quarter. So the easiest way to find 25% is to divide by 4. So we need to find 25% of 300, which means I'm going to do 300 divided by 4. So 300 divided by 4, which is equal to 75. So I know that this here represents 75 people. So the amount of people which is from between, in this kind of the very top quarter, is 75. Brilliant. So there was example, I've lost my examples now. I think it was example 7 or 8. So what I'd like you to do is pause now and have a little go at that question on the right. So pause now and have a little go at that question on the right. Okay, let's have a look at this one together then. So with this question here, it says there were 80 players in college sample. Work out the number of players who ran a distance of 5.6. So if I look at where 5.6 lies, again, 5.6 lies at the upper quartile. So example 8, 5.6 lies here, 5.6. So I just need to find 25% of this. It's worth noting that if 5.6 was here, let's say, I know it's not, and we wanted to see the amount of people, that would be all of this part here, which is 75%, okay? So I'd want to find 75% if it was this part here. But it's not, okay? So it is the upper quartile. It's the same as the one we've just done. don't want to mess with that. So let's get this one down. So we've got here, this here. So 5.6 is here, so we need to find 25% of this, which is 25% of 80. So 25% of 80 is 80 divided by 4, which we can probably do in our head, which is 20. So we know that there are 20 people in this part here. Let's have a little check of that. 75 and 20, brilliant. Remember, it's about splitting it up into quarters. So I know that each of these quarters here, in this one, would be worth 75, 75, 75, and 75. And each of these quarters would be 20. So it's 20, 20, 20, and 20. Each of these quarters, brilliant. Okay, so let's have a little go at some of these questions now. So I will make this big for you so you can see it. So pause now and have a little go at those questions. There is another sheet here, so there's only 8 on here. There's another 8 on the next page. So pause now and have a go at those first 8. Okay, let's have a look at those next 8 now. So pause now and have a little go at those next 8. Okay, so I'm going to pop the answers up for these. So mark these in green. Mark them in green. Okay, so thank you for watching this video on Box Blocks. Do make sure you're having a go at these questions, because remember, the only way to learn maths is to do it, and have a lovely day.